Okay. Can everyone hear me okay? I think we're just waiting for a few more people to join us for the total number. So I will just give you a few more minutes. Too many screens, right? Okay, well, we're up to sort of 20 participants now. I think we're expecting sort of a few more, but I'm sure they'll filter in. Welcome to everyone who's joined us. Thank you very much for joining this webinar. This is the first of a trio of webinars in which we will be celebrating some of the collaborations we've had with industry. Today, we'll be hearing from two businesses directly that we've supported to bring a new product to market. So it's one of the three themes that we'll be following across this series. By way of reminder, for those who haven't necessarily used Zoom that much or aren't familiar with the webinar format, there's a Q&A function as well as a chat function. So if I can remind you to feel free to ask questions, obviously, but if you can use them in the Q&A section to ask those questions so we can respond to them properly. But feel free to introduce yourselves and use the chat function to discuss things and sort of make comments along the way. That's absolutely fine. And also then, by way of a swift introduction to Specific, because I don't know exactly who's attending and what your level of knowledge of what we do is. And we haven't got much time, but I'll cover it quickly. Specific is a UK National Innovation and Knowledge Centre. It's led by Swansea University with strategic industrial partners, including Tata Steel, AkzoNobel, and SG Pilkington, and has lots of other academic partners, including Cardiff University. Specific's vision is to transform the world of energy by creating active buildings that can generate, store, and release solar energy. It is the only UK centre that is developing building integrated solutions combining solar thermal and heat storage with photovoltaics and electrical storage. Specific and its partners support the commercialisation of disruptive technologies by taking the concept from research through to full-scale demonstration. And Specific is funded by EPSRC, Innovate UK, and the European Regional Development Fund through Welsh Government. So now I've covered that off, I'd like to introduce our two companies and the speakers of them. So we've got Biofresh Group Limited and Jonathan, who's with us today as well. Welcome, Jonathan. And we've also got Solapak Development Limited and Zaki, who's with us today on behalf of them. Hi to you both. And from Specific then, we've also got my colleague Sophie Phelps, who's our Project Impact Officer, and also representatives in our sort of marketing team as well, who are helping us to make things run smoothly today. So we've got Ella on the call as well, who'll be able to chip in, maybe help answer some questions as we go through. So I think we're going to start with Jonathan, is that correct? Yeah, Jonathan's going to start first from Biofresh, and basically just going to hear a little bit from him about a novel decontamination system, which is a little bit off the wall for Specific, but it's really in relation to sort of a COVID response. It's very much of the time and the challenges that we were facing, and I'll let Jonathan tell you more about that. Thank you, Jonathan.
Thanks, Chris. Hi, I'm Jonathan Caseley, Managing Director of Biofresh Group Limited. I'd like to start, first of all, just to give a bit of background to Biofresh as a company, what our core business is and where we came from, how we got involved in this project. Biofresh was established in 2003 as a spin-out company from the University of Newcastle to commercialise long-term research which had been done there on a variety of chemical residue-free treatments for the preservation of fresh produce in storage to reduce spoilage and extend shelf life. We became independent from the university in 2011, and as we expanded into export markets and branched out into new fields, we developed some of those technologies for other sectors, notably ozone for use as a sanitizer in areas such as hotels and hospitality, care homes and health sector. We have 2 production sites. One is in Huddersfield, the other in Washington, Tyne and Wear, and sales office in Northumberland, and a couple of subsidiary companies in Italy and Australia to help support our export business. The project with Specific and the University of Swansea really centres around ozone as for use in sanitisation, rapid sanitisation of schoolrooms. So I'd like to give a very brief explanation of ozone and how it works. Ozone is a naturally occurring gas which is created from oxygen within the rooms which are being treated. So it doesn't require any additional fuel or chemicals. It just needs the electricity to run the unit itself. So use of ozone is a very simple process. It's just a matter of putting the unit in the area to be treated, choosing the cycle according to the protocol that's been specified. The area should then be cleared, and the unit can be switched on either manually on the unit itself or remotely via an app. The ozone then, the unit then creates the ozone, which ozone is a very oxidative agent, and so the ozone will react with odors, fungus, bacteria and viruses in the environment to sanitize them. When that treatment period has been completed, then the unit goes into an ozone destruct cycle to return the ozone back to the original oxygen from which it was taken and to make the room safe for re-entry. Working with ozone, apart from being easy to use and cost efficient, another advantage of working with ozone is as a gas, it really penetrates throughout the room and reaches areas which would be quite difficult to reach with a physical or manual cleaning process. What we found at the beginning of the pandemic was that obviously there was a very high interest in ozone as a sanitizer, and the units that we had and were out on the market generally tended to be either small portable handheld units used for the kind of applications we can see in the bottom left here, so on public transport, in hotel rooms, in care homes. Or there would be the much more powerful units which are used in industry and agriculture, which are less mobile. They're very powerful, but less mobile, and so wouldn't really be suitable for use in schools. So the challenge that was set was to produce an easily mobile sanitization unit capable of rapid treatment of school classrooms at an affordable cost to work within school budgets. The areas that we're treating tend to be in the region of 150 to 250 cubic meters, around about that size. And so what we needed to do was combine really the power of the larger units with the portability of the smaller units. In terms of the process and the project as we got going, I think there were really 2 main phases. The first phase being the development work done together with the university. And the University of Swansea is known worldwide as a centre of knowledge for ozone, and has been active in research for many years for it. And so to be able to tap into their knowledge was of huge benefit to us. And really that was in various aspects of their knowledge of ozone. So knowledge of ozone and the generation of ozone, so we could look at our processes and see if we could improve the efficiency of our unit. There was the way that the ozone reacts in different environments according to humidity and temperature and such things, the way that ozone reacts with the contaminants. And also a really important part was the distribution of air within the rooms to be treated, because obviously it's critical that we get a good distribution to fully sanitize, particularly in a large area like a school classroom, to make sure it was getting in all areas that it would need to be. And we learned a lot as a result of the support from Swansea for that. The second stage was, having made the alterations in the unit, was really to get units out and test the results. And Swansea and Specific were very helpful in setting up field trials in local schools, which we got some fantastic feedback on, not just the data showing the benefits of the improvements that we've made, but also getting feedback from the schools in terms of the ease of use of the unit. And we took a number of their suggestions on board and have made some changes in the design as a result of that. So the key outcomes that we were able to achieve as a result of the project, we were able to develop a significantly more powerful ozone production cell. Approximately, we would say around about 50% increase in output compared to what we were doing before, which really helps in terms of a rapid sanitization of a classroom. We changed the design to extend the original unit into 2 separate chambers, which made the unit a bit larger, but made it much more efficient, separating the chambers where ozone is produced and where it's destroyed. As we were developing that, we also got advice from the university in terms of the physical layout of the unit. So originally we were looking at a horizontal unit, like the one in the second photograph on the left-hand side in the progression of the unit. We were looking at that originally, but the university was suggesting, so that if we made it a more vertical unit, we would get better distribution of the ozone throughout the room. And we also made some changes based on feedback from the schools in terms of ease of use. So making it a wheeled unit for easy mobility, and putting handles on the side as well as the top, again, to get it around easily. And we made some changes in the app also to improve the reporting and accountability process. So at the end, we have a unit which is a powerful unit, but still easily mobile, with programs from 15 minutes up to 7 hours, depending on the size of the room and the application, which can be used via the app. So the caretaker can be outside of the room throughout the entire duration of the treatment cycle. In terms of taking the project forward, the technical developments that we've been working on with the university, we will continue with those from the information that we've learned. We have some ideas from that, which we will be doing further development on the ozone cell design to increase the capacity, and also changes in the app to further improve functionality and traceability. For the unit as it is, the next challenge is to get it out to the schools, and we're working with the Welsh Government on that. And as part of that process, we are further developing educational literature and presentations on the nature of ozone itself, so that the schools that will be using the unit can understand how ozone works, understand the safety features and all of the aspects of ozone. Further, we will be looking at new applications. We see possibilities in healthcare, hospitality and leisure centres, and also in some of the existing areas where we're working with a smaller unit, where a more powerful unit will allow a more rapid treatment. And so we see lots of opportunities ongoing for that. Moving on to, let's see, there's a question here regarding being asked, were there any concerns from schools about using ozone? as it is less well known in cleaning treatments. Yes, I think that really that is one of the biggest challenges of getting ozone widely adopted in many sectors, because it is a relatively unknown sanitization process. And really that leads into the point that I was making in terms of the need for further educational information, not just for the schools themselves, but also for caretakers as well, to understand the safety of the unit, and also the effectiveness of ozone as a sanitizer.
Perfect. I think sorry, I was going to say, I think if we can, just because of time, and we have got quite a short window of opportunity to hear both presentations. I think if we can feel free to ask more questions in the Q&A, and we'll come back to those with at the end of both presentations, if that's okay, just to make sure that we can cover off those first, and then obviously if we overrun, we're overrunning into Q&A rather than presentations. So I'll ask you to finish. Thank you very much, Jonathan, and really exciting to hear about that and sort of understand the development process. Zaki, if you would join us now as well, please. I'd like to introduce Zaki from Solapak. Solapak has been developing a remote monitoring system for PV and batteries at milk cooling centres in Rwanda. So I'll let him tell you more about that. Thank you, Zaki.
Thank you very much, Chris. Hello and welcome to the webinar. My name is Zaki, and I am the lead project manager at Solapak Development Limited, where we are in the process of developing a clean energy solution for developing world rural dairy communities. A bit about me. I've been working in the solar industry for the past 15 years, and I've seen it evolve over years to becoming a contributor to fuel economies around the globe. I joined SDL in July 2020. Previously, I have been involved in the state-of-the-art research center in United Arab Emirates, where I supervised many projects related to solar energy solution development and contributed to publications and presented our work in conferences and workshops in Europe, America, and Japan, to name a few. I have also been involved in consultancy to help develop sustainable solar solutions in the MENA region. So without further ado, I'll like to start the presentation. Yeah. So today, in the next 10 minutes or so, I would like to tell you a bit about Solapak Development Limited's work in developing new solutions for energy poor rural dairy communities in developing world countries, and how the team at Specific have supported us. As Solapak System Limited, we have for 40 years specialized in the provision of standalone solar electric generators in industrial applications such as telecom, oil and gas, and critical safety systems. These systems are proven reliable and fit for purpose in remote locations where they are fully automatic and operate without any human intervention. The electrical load they power is accurately defined by the client and operates within strict tolerances. The image displayed in front of you shows Solapak System Limited's installation on Jebel Mountains in Oman, and the one with the helicopter dates back to early 80s. Solar power systems enable Oman's first national communications backbone linking the north and south populated region of the country. Solar has to be used on Jebel Mountains because many paths were inaccessible by land. Imagine if you need to maintain an energy system using a helicopter, the reliability of system becomes financially very valuable. That is why, despite a standalone PV system in the 80s using only 66% efficient cells, not having the benefit of solid-state electronics, and being multiple times more expensive than they are today, it was still a cost-effective solution for the client. In 2016, Solapak System Limited committed to directing its specialist skills, supply network, and global reputation towards international development. Solapak Development Limited, or SDL, was subsequently formed to build upon the reputation of Solapak System Limited and to deliver those commitments to international development. Having undergone lengthy feasibility studies, SDL specializes in holistic energy solution for developing world rural dairy communities. For this, we have undertaken multiple visits to Africa, particularly Rwanda, to develop first-hand deep understanding of the challenges that lies within these communities. This differentiates our approach from many who are ready to provide solar energy solution only. Our current project is focused on Milk Chilling Center, as Chris defined, also called MCCs in rural Rwanda. We have spent the past 12 months engaging with cooperatives that run these MCCs and the communities they rely on them. Most families in Rwanda own one or more cows, and delivering their milk to MCC provide them with income and enables a nationwide milk delivery system. The photo on the right shows a hauler who often uses bicycle and not necessarily motorbike to carry canisters of milk to these MCCs and can travel from as far as 15 to 20 miles every day. We will soon be deploying the system to power milk chilling loads and provide energy services to the neighboring community. We then have many more variables than when powering an industrial load. One amongst them are the changing seasons that not only affect the solar generation, but also impact local milk production, and a dramatic departure from the normal operation could lead to an energy shortfall. Furthermore, our business model and economic viability of these systems hinges on utilizing the spare generation capacity of the solar power generation beyond that simply required for chilling milk to enable energy services for the local community, and that also is a unique feature with us. The photo on the left shows the milk chiller powered by diesel generator using unreliable electrical connections. For these reasons and more, we need to deploy our standalone solar generators with complete monitoring system that collects data on both the energy system and on key parts of the milk chilling operation. This comprehensive monitoring system will ensure correct and reliable system operation and maximize value. Such a complex system is not something Solapak has had to do in the past due to the straightforward nature of their industrial loads and the absence of any community engagement. This is where the expertise of Specific helped us. Just to let you know, there are synergies which SDL and Specific share. SDL and Specific are both committed to increase use of renewable energy technologies, and through their Sunrise project, Specific are also taking solar energy to rural villages in India. SDL have followed the progress of the Sunrise project, attended their conferences, and held discussions with Sunrise participants on choice of battery technology and PV module design. It soon became clear to us that Specific have proven expertise on implementing comprehensive monitoring system for energy generation and consumption in their active buildings, and were an obvious choice for us to approach for support. Just as with our system in Rwanda, the behavior of the users of the building would play an important role in the building energy consumption. In order to come up with a holistic design, SDL presented Specific with a wish list parameters to monitor remotely away from our main power grid. Specific then presented us with options of how measurements could be taken, recorded, and the data transmitted. With each option, due consideration was given to accuracy, ease of calibration, reliability, accessibility, and cost. With monitoring solution ranging from tens of pounds to many thousands of pounds, the cost element was a key requirement whilst maintaining the required accuracy and reliability. The schematic on the screen shows the existing design we are about to execute. The system will remotely be connected to the sensors installed in Rwanda via cloud server. The analytics and monitored data will be available via web portal anywhere in the world, which will be one of its kind implemented for this type of system. The support received from Specific enabled SDL to fully specify and design monitoring system for the 2 MCCs in Rwanda. Having procured the hardware and undertaken firmware development, the system will finally be assembled and tested at Specific prior to deployment in Rwanda. The photo displayed on the screen are recently taken, showing a couple of sensors undergoing firmware development. Having the support of Specific has enabled us to reach this point, both on time and within budget. The next step for SDL are to install the PV energy system and monitoring system in Rwanda. Water plays an important role in the operation of MCCs, and our monitoring system will track water use as well as energy use. Additionally, we will ensure that each center is able to collect and store sufficient rainwater to be self-sufficient in this regard. The monitor data will be used to refine our business model and ensure our work benefits those dependent on the MCCs for their livelihood, raising the income of dairy farmers and those in their community. We know this work is of interest to Specific, particularly being within the nexus of energy, food, and water. And the real world challenges we encounter can help to define Specific's future research. Where Specific is looking to implement solar energy solutions, whether in India, Africa, or elsewhere, SDL can support with the provisions of reliable standalone energy solutions. In this short presentation, I have tried to provide you with a glimpse of what we are trying to achieve. However, there are lots of work being executed in the background with the help of our partner listed here, spread across the globe. Please visit our website to know more or email me, and I would be happy to share my experiences related to this project and my engagement with Specific. Finally, I would like to thank you all for your attention, and I'm ready to take your questions. Thank you.
That's fantastic. Thank you very much, Zaki. Wonderful to hear about that project and the work that's been going on between us, Specific and Solapak. Jonathan, if you'd like to join us again as well. We'll just, obviously there's questions coming through now. So I think this one is for Zaki. How much does the monitoring system cost and what will happen with it after the project finishes?
Yeah, so that's a very interesting question. So basically, the initial cost that we have incurred for the two MCCs is around 10 to 15,000 pounds, but that includes the development cost as well. However, as our plan is to go ahead and do this, replicate this design to various other MCCs, the cost will be significantly down. So the next question is, what are we going to use? Yes, definitely. We are going to use, because at this moment of time in Rwanda, weather forecasting isn't there. We are going to install a very accurate weather forecasting system, which will help to gain the actual weather forecasting and prediction for the region. So that can be shared. Apart from that, the knowledge base that we'll develop from this would be immense. We have already started doing that by understanding how the community, how the milk chilling center work, what are the problems that they are facing. One short example that I'll give you is, we were looking into the system. So they have milk chillers and they have the chilling units. So the chilling units have outdoor units and indoor units. What they did was to put both of them inside. Now, when we tried to look in the energy consumption, because we were monitoring the energy data, we were like seeing the COP, the coefficient of performance of the chilling, was very low, and we couldn't understand why exactly. However, with different tests that we conducted, we found out that the outdoor chilling unit was heating the room, and hence the delta T was changed that affected the COP. So these are some of the valuable things that we are gaining from this, and we would continue to do so, which could be really, really helpful when we actually go for implementation.
Sure. Brilliant. Thank you for that. There's a couple of questions come in. I'm aware of the time. Obviously, if anyone needs to leave, I appreciate that's, you're welcome to, and we're recording this webinar and it will be sent out afterwards to those who have to leave now. But we're going to carry on with the Q&A if that's okay, for those of you who are here still. For Jonathan, then, were there any? Well, it says, yeah, were there any concerns from schools about using ozone in particular, as it was a less well-known cleaning treatment? Yeah.
Yes, I think that that is an obstacle that we sometimes have to come across, and I think it is essential as part of the process, and it's something we spoke about as part of the project, as to how we can educate the users better about the background to ozone. I think that is certainly an important feature, and it involved, that was apparent from the testing that was done this time.
Excellent. And there's another one here for Zaki. What size are the PV systems that you've installed in Rwanda?
So we are in the process of installing the system. So we have got 2 MCCs, and the range, just to give you, will be around, for the PV module, it will be around 15 to 40 kilowatt peak of PV module. And with regards to the storage or the battery, it would be around 20 to 90 kilowatt hour battery that we are looking at. And that will take in the spare capacity that we would like to have for excess that we can give it to the community.
Yeah, excellent. Do we have any more questions coming in from those who are still with us? Obviously, as I said, this will be this is the first of a series of webinars, so there's going to be 2 more coming in the next couple of weeks. We've got one on May 27th, which is about helping businesses run more sustainably, where we're going to hear from Surfability and Transport for Wales. We've also got one on the 3rd of June, where we will be looking at how we've helped improve existing products and processes, and that will be with a company called Measurable and Carbon Track. So appreciate we're over time now, and I thank you very much for the questions that have come in, and thank you to our presenters, Jonathan and Zaki. Obviously, if you've got any more questions, I'm sure they'll be perfectly willing to answer them hereafter, and you're welcome to send them through to us. And if you'd like to know more about their project and how they might progress going forward, then you're welcome to get in touch. But otherwise, thank you very much, and thank you for joining us. Bye all.